When I was initially making this worksheet, I debated whether or not to give you 2 examples or 4 examples of adding and subtracting rational expressions with uncommon denominators. Ultimately, I decided to do 4 parts for example 4, simply because this is probably the hardest part of dealing with rational expressions. Everything leading up to this, not too bad. Everything after this, not too bad. It's the adding and subtracting with the uncommon denominator. So we will have 4 examples, so this video is going to be a bit longer, okay? So here are the steps to take. First, we have to find an LCD for the rational expressions. And remember, before we can find the LCD, we need to make sure our denominators are all in factored forms. There's kind of like pre-step 1, which is factor your denominators, and then step 1, find the LCD. Step 2 is rewrite each rational expression as an equivalent expression whose denominator is the LCD. And remember, the way we do that is we multiply the numerator and denominator by the polynomial that'll force our denominator to become the LCD. Then we do the adding and subtracting of the numerators, and you have to be very, very cautious here, especially with subtraction, okay? When you're subtracting, you need to distribute a -1 through that second numerator and then do your adding and subtracting. We have to subtract the entire second numerator. So to do that, just distribute a -1 through the second numerator, then do your adding and subtracting. Simplify and place that sum or difference over the common denominator. And then the last step is to make sure everything is factored and simplified. Okay, so for example 4, we're going to find each sum or difference. And like I said, there are 4 parts here. So this video is going to be a bit lengthy, but I think it'll be worthwhile because, like I said, this is the hardest part and we need to see as much as we can. Okay, so for part A, we have 2x minus 6 all over x squared minus x minus 6, and then we have plus x plus 4 over x plus 2. So the second denominator is fully factored. The first one needs some work, okay? So looking at my first denominator, I have x squared minus x minus 6. Luckily, this is a quadratic trinomial where a is 1. That means we can take the shortcut factoring. We start each binomial with an x factor. That way, when we multiply x times x, we get the x squared. Now what we need to do is we need to find factors of -6 that have a sum of -1. So we could try -6 and 1. We could try 6 and -1. We could try -3 and 2, or we could try 3 and -2. So which of those 4 pairs of factors has the correct sum? Well, I need a sum of -1. So if I take -3 and +2, when I multiply them, I get -6, but when I add them, I get the -1. So we're going to fill in factors of -3 and +2. Okay. Now, in this case, finding the LCD, I think, is pretty easy. A lot of you probably already know what the LCD is, but let's go ahead and do the table just to be safe. So we've got our first denominator, our second denominator, a row for each of those, and then we have a row for the LCD. So fill in one of your 2 denominators. I generally fill in the denominator that has the most factors first, but it really doesn't matter. I am going to start with x minus 3 times x plus 2. Now, the first column can only have x minus 3's in it. The second column can only have x plus 2's in it. Where do we put our second denominator? Well, our second denominator is x plus 2. It cannot go in the first column. It has to go in the second column. And then we just bring down the representative from each column. So basically, like, the product of what each type of column we have becomes the LCD. So I have an x minus 3 column. I have an x plus 2 column. This right here, let me change colors so it's really obvious. This right here is the LCD, okay? So my first expression already has the LCD as the denominator, okay? So I don't need to do anything to that first expression. The second expression needs some work, okay? So I have x plus 4 over x plus 2. I need to rewrite that where I have the LCD as my denominator. So we ask ourselves, what do we multiply that denominator by, the initial denominator of x plus 2 by, to get the LCD? Well, what's missing is x minus 3. So I'm going to multiply the second denominator by x minus 3. But if I multiply the denominator, I have to also multiply the numerator. So we're going to get, I'm going to go ahead and just leave this in factored form. We'll deal with foiling it later. So our numerator becomes x plus 4, x minus 3. Okay, so over here, what we're going to end up with is 2x minus 6 all over x squared minus x. Well, let me write that in factored form. We're going to write it as x minus 3, x minus 2. That way it's really obvious, or x minus 3, x plus 2. That way it's really obvious that we have the same denominator. Plus, I now have x plus 4 times x minus 3 all over x minus 3, x plus 2. Now it is really clear to see that we have the same denominator. We can proceed with adding our rational expressions. So to add our rational expressions, we just add the numerators and then keep the common denominator. So that's going to give me 2x minus 6 plus x plus 4 times x minus 3 all over the LCD, which is x minus 3, x plus 2. I need to do some work on my numerator. So the first thing I need to do is FOIL that second numerator, that x plus 4, x minus 3. So my 2x minus 6, I'm just going to rewrite it. And then x plus 4 times x minus 3, I get x squared minus 3x plus 4x minus 12 all over x minus 3 times x plus 2. So let's do some simplifying here. I am going to move this kind of over here just because I'm running out of room. So let's see, I've got, when I simplify, I've got x squared. So that's been taken care of. The x terms, let's see, I've got 2x minus 3x plus 4. So let's see, 2x minus 3x is negative x. Negative x plus 4x is 3x. So those have all been taken care of. And then I have negative 6 minus 12, which is negative 18. And that is all over my denominator of x minus 3, x plus 2. Okay, so at this point, if we go back to the steps, we found the LCD, we found equivalent rational expressions, we added or subtracted the numerators, we were able to simplify and place that sum or difference over the common denominator. The last step that we have to do is this right here. We need to factor and simplify. So the numerator here does need to be factored, okay? Luckily, I have a quadratic trinomial where a is 1. So the factored form of x squared plus 3x minus 18 is going to start with two binomials, each binomial starting with an x. And then I'm looking for factors of negative 18 that have a sum of 3. So I could do negative 18 and 1, 18 and negative 1, negative 9 and 2, 9 and negative 2, negative 6 and 3, or 6 and negative 3. So which of those pairs of factors adds to 3? Well, this pair right here. So we're going to go plus 6 minus 3. That's going to go over the denominator of x minus 3, x plus 2. And finally, after what feels like an eternity, does anything cancel? Yes, we have an x minus 3 in the numerator and an x minus 3 in the denominator. Excuse me. X minus 3 divided by x minus 3 is just 1. So that tells me my final answer is x plus 6 over x plus 2. So a lot of work, several steps. Like I said, this is probably the hardest part of just dealing with rational expressions, is adding and subtracting rational expressions with uncommon denominators. It's a lot of steps. Just take it nice and slow and be organized with your work, okay? Now I need a quick water break, and then we'll look at part B. Okay, hold tight. Okay, so let's look at part B. So for part B, we have 2 over x squared minus 4 minus x plus 1 over x squared minus 2x. Let's get to factoring. Our first denominator is the difference of squares. So we need to figure out the square root of x squared. It's just x. The square root of 4 is 2. So my first denominator factors as x plus 2, x minus 2. And then my second denominator, it looks like we just have a GCF of x. So I'm going to factor out x, and I'm left with x minus 2. So then we're going to come over and we're going to do the LCD table. So I've got my first denominator, my second denominator, and then my LCD. It does not matter which denominator you start writing out. I think I'm going to start with my second denominator because I have that weird little factor of just x. So my second denominator is x times x minus 2. I then want to fill in the second denominator in this table. I want to overlap as many columns as I can. If I can't overlap columns, I start a new one. So my first factor of my first denominator is x plus 2. I cannot put it in the first column. The only thing that can go there is a plain x. I cannot put it in the second column because the only thing that can go in the second column is an x minus 2. So I have to start a new column for x plus 2. So that takes care of this factor right here. And then my second denominator, or my second factor in my first denominator, is x minus 2, and I can overlap that. That can go in the second column, which is right here. So when I bring down the representative from each column, I get an x factor in my LCD, an x minus 2 factor, and an x plus 2 factor. So that becomes my new LCD. So this right here in blue is the LCD. Now we need to get equivalent forms of both of these rational expressions. So let's do a little work off to the side. I have 2 over x plus 2, x minus 2. And in order to get the LCD, I would have to multiply the numerator and denominator by x. So I'm going to multiply top and bottom by x. And that's going to give me 2x over the LCD. For my second expression, I have x plus 1 all over x times x minus 2. There we go. I need to convert that to the LCD, which is x times x plus 2 times x minus 2. What's missing from my second denominator compared to the LCD is an x plus 2 factor. So I multiply top and bottom by x plus 2. And I'm going to go ahead and FOIL that second numerator. So let's see, x times x is x squared. X times 2 is 2x. 1 times x is x. And 1 times 2 is 2, which gives me x squared plus 3x plus 2 over the LCD. So that's going to be my second expression, okay? So let's go back over here and see what we have. So our first expression is now 2x over, I'm just going to write out LCD. We know what the LCD actually is. Minus the second numerator of x squared plus 3x plus 2 over, again, we're just going to put LCD. We know what the actual LCD is. So when I go to add or subtract my numerators, remember, we have to subtract this entire second numerator. In order to do that, I need to distribute a -1. Please don't forget that. If you forget to distribute the -1, you could very well end up with the wrong numerator, okay? So my numerators are going to be 2x, and then I'm going to distribute that -1, so I'm going to get minus x squared minus 3x minus 2 all over the LCD of x times x plus 2 times x minus 2. Okay, so now let's see what we get when we simplify. My numerator, I have a -x squared. 2x minus 3x is -x. Minus 2 is just minus 2. All over x times x plus 2 times x minus 2. Let's see if we can factor out a -1 in the numerator. Okay, so we're at that point where we've got the sum or difference of the numerators over the denominator. We need to see if we can simplify the denominator. So I would start by factoring out an LCD of just, or an LCD, a GCF of just 1. So that would make that -1 times x squared plus x plus 2. So I think I said a GCF of 1. I meant a GCF of -1. All over x times x plus 2 times x minus 2. So let's see, can we factor that numerator anymore? Are there factors of 2 that have a sum of 1? No. So when we're looking here, there are not factors of 2 that have a sum of 1. The factors of 2 are just -2 and -1, which has a sum of -3. The factors of 2 could also be 2 and 1, which have a sum of just +3. There's no way to continue factoring. So we would say our final answer is going to be negative x squared plus x plus 2 all over the LCD, which is x times x plus 2 times x minus 2. And again, I'm going to put it in a box so you know that this right here is the final answer. All right, so there you have it. Again, it's a lot of work, it's a lot of steps, but each step individually isn't that bad. You just have to take it nice and slow. Okay, let's go ahead and look at part C. So again, I warned you this is going to be a longer video, but we'll do what we can. All right, so for part C, we have 2x over x squared plus 5x plus 6 minus x plus 1 over x squared plus 2x minus 3. So let's see, we need to factor both denominators. Both, luckily, are quadratic trinomials where the denominators have, where the coefficient of the square term is 1. So for the first one, I need factors of 6 that add to 5. That would just be 3 and 2. So I get x plus 3, x plus 2. For the second denominator, again, the coefficient of the squared term is 1, which is great. We need to find factors of -3 that have a sum of 2. Well, factors of -3 are -3 and 1 or 3 and -1. This pair right here, when we add, has the correct sum. So this is going to be x plus 3, x minus 1. Now we go to the LCD table. So let's see, when we do the LCD, first denominator, second denominator, LCD. First denominator, I just have x plus 3 times x plus 2. For my second denominator, I have an x plus 3, so I can overlap there. But then my second factor is x minus 1, and that cannot go in the second column because the only thing that can go in the second column is an x plus 2. So I start a new column for my x minus 1. And then we're going to take down the representative from each of those 3 columns, and that becomes the LCD. So my LCD is x plus 3 times x plus 2 times x minus 1. So this right here is the LCD. All right, so now let's find equivalent forms of both of our expressions. So if we look at the first expression, what's missing from the LCD is the x minus 1. So I would just take 2x times x minus 1 and put it over the LCD. What's missing from the second denominator is the x plus 2. So I'm going to take my x plus 1 times x plus 2 and then put that over x plus 3, x plus 2, x minus 1. Be super duper careful because we have to subtract the entire second numerator. So let's see what we get. We're going to do some distributing and some foiling, and then we're going to distribute that -1 and simplify our numerator. So for the first numerator, I'm going to get 2x squared minus 2x, and that's just going to be over the LCD. For the second numerator, let's see, we're going to get x squared plus 2x plus x plus 2. So let's go ahead and combine like terms in the middle. The middle, we're going to get just 3x. So I'm just going to do that all in one step. So plus 3x plus 2 over the LCD. And now we have to distribute that -1. Okay. So my numerators combined are going to be 2x squared minus 2x. Don't forget we have a -1 here. So I'm going to get minus x squared minus 3x minus 2. We just distributed a -1. That's all we've done in that step. And all of that is going to go over the LCD, which is x plus 3, x plus 2, x minus 1. This is exhausting, right? And then let's simplify our numerator. So our numerator, let's see, we have 2x squared minus x squared. So I'm going to bring this kind of up here. So that's going to give me just x squared. So that takes care of these two terms. I now have -2x minus 3x, which is -5x. So that takes care of these two terms. And then I have what? -2 all over x plus 3, x plus 2, x minus 1. And the last, praise goodness, step is determining if we can factor our numerator. So we're at that point where we've found the LCD, we found the equivalent expressions, we were able to distribute the negative through our second denominator, we were able to simplify, and now we have x squared minus 5x minus 2. So are there factors of -2 that have a sum of -5? Well, factors of -2 are -2 and 1 or 2 and -1. And neither of those pairs of factors will ever add up to be -5. So this right here is our final answer. It's ugly. You always kind of like in your heart, you want it to simplify, but sometimes that's as good as it's going to get, okay? Finally, last example, part D, we have 3 expressions. So that means we have to find an LCD for 3 expressions. We need to find 3 equivalent expressions and then see what happens from there. So our first 2 denominators are factored. So x plus 2 and x are as good as they're going to get. The third denominator is just the difference of squares. So it's x plus 2 times x minus 2 when factored. Okay. And let me see here. I think I'm going to go straight down for the LCD. So I've got my first denominator, my second denominator, my third denominator, and then my LCD. So I'm going to start with the middle denominator just because it just has that single term as the denominator. So we're going to go x there. I'll then fill in my first denominator, which is x plus 2, and it cannot go in the first column because the first column is for just a plain old x. So I'm going to start a new column for the x plus 2. My third denominator, I can fill in an x plus 2 in the second column. And then my x minus 2 can't go in the second or first column, so I have to start a new column. So that tells me my LCD has an x factor, an x plus 2 factor, and an x minus 2 factor. So this right here is the LCD. All right, we need to find our equivalent form, so we're going to have to do this 3 times. So 2 over x plus 2, I'm going to have to multiply that by x and x minus 2. For the middle expression, I have 3 over x. I need to multiply that by x plus 2, x minus 2, top and bottom. And for the third expression, I have x plus 10 over x plus 2, x minus 2. I just need to multiply top and bottom by x. So let's see what that's going to end up looking like. It's going to be a little bit messy at first, but we'll get there. So I'm going to kind of split my screen like this so we can see. So let's see. For my first expression, I get 2x times x minus 2. My second expression, I'm subtracting, so I'm going to get minus 3 times x plus 2, x minus 2. My third expression, I'm adding, so I'm going to get x times x plus 10 all over x times x plus 2 times x minus 2. Okay, so I've taken my numerators, we've combined them. We now need to distribute, do some foiling. We got to get this fully simplified, and then we're going to see if we can factor and simplify. Big deep breath. Okay, so first thing I want to do in my numerator is I want to FOIL that middle part, the x plus 2, x minus 2. And luckily, we already know what x plus 2 times x minus 2 is. It's just x squared minus 4. Hopefully you don't have to do the actual foiling. If you need to do the actual foiling, pause this video, do the foiling, and move on. So we're going to end up with 2x times x minus 2 minus 3 times x squared minus 4 plus x times x plus 10 all over x times x plus 2, x minus 2. Okay, now we can distribute. We're going to distribute in 3 places. So first we get 2x times x, which is 2x squared. 2x times negative 2 is negative 4x. Negative 3 times x squared is negative 3x squared. Negative 3 times 4 is plus 12. X times x is x squared. X times 10 is 10x. All of that is over the LCD. Let me just double check and make sure I didn't miss a sign. 2x squared, negative 4x, negative 3x squared, plus 12. Okay, I think we're good. So now we want to combine like terms. Finally, we want to combine like terms in the numerator. So let's see here. We've got 2x squared minus 3x squared is negative x squared, plus x squared is just 0. So 2x squared minus 3x squared plus x squared, that just becomes 0. Let's see, negative 4x minus 10x is 6x. So we're done with these 2 terms. And then finally, we just have a plus 12 in the numerator, so that simplified nicely. And that's x over x plus 2, x minus 2. Let's see if we can factor. I'm worn out. I don't know about you. Let's see. We can factor out a 6 in the numerator, so that's going to give me 6 times x plus 2 all over x times x plus 2, x minus 2. Ask yourself, does anything cancel? Hopefully you're all shouting from the rooftops, yes, we have an x plus 2 that cancels. So x plus 2 divided by x plus 2 is just 1. And that leaves me with a final answer of 6 over x times x minus 2. And praise goodness, we are done. So again, I kind of knew coming into this that this was going to be a very long section of the video and a long worksheet. But I think seeing 4 examples of this is hopefully worthwhile. These are messy. They're not the easiest thing you're ever going to do. Each individual step is not bad. The individual steps are fine. It's just kind of putting it all together in one problem. It's a lot. So number 1, be kind to yourself. Number 2, take it nice and slow. Be very organized. Okay.